In this lesson, we are going to start our discussion on photoelectric effect. First thing we need to learn is emission of electrons. If you look at a conductor, a metal, electrons are moving randomly, right? Random motion of electrons. These electrons move randomly inside the metal, but they do not come out. Electron can be here, but it will not come out. We need to give it some energy to make it come out of the metal surface. The minimum energy that needs to be given to an electron to make it come out of the metal surface is called work function of that metal. If the electron is on the surface, you give an energy equal to work function, it will come out. For other electrons to come out, we need an energy more than the work function. And then the electron comes out. So work function is the minimum energy that needs to be given to an electron to make it come out of a metal surface. Now we can give this energy in a number of ways, and depending on the source of energy, we can have number of methods of making the electron come out. We can give energy as heat. That process is called thermionic emission. This we learned when we learned about X-rays. Like when you heat water, water vapor comes out. When you heat a metal surface, then electrons come out. This process is called thermionic emission. Therm means heat. And the electron coming out by this process are called thermions. They are electrons only, but they have been given a special name, thermions. Now, we can also make the electron come out by applying a strong electric field. That is called field emission. So this is a metal. Suppose you got a positively charged plate here. Then this can pull out some electrons. So these electrons get sucked out. That is called field emission. We can also have secondary emission. Some metal surface is there, like we had the target in production of X-rays. When they get bombarded by high-speed electrons or even other particles, some electrons can get knocked off and they come out. That is called secondary emission. The most wonderful method to make the electron come out is by giving energy in the form of light or some other electromagnetic wave. And then the electron comes out. This is what is photoelectric effect. When light of appropriate frequency or appropriate wavelength is incident on a metallic surface, electrons are liberated from that surface. This is called photoelectric effect. This was discovered by Hertz in 1887. He and his students studied this in detail, and whatever observations they made could not be explained by wave theory of light. Einstein in 1905 took light as a particle to explain photoelectric effect, and for this Einstein got the Nobel Prize in 1921. Now for photoelectric effect to occur, the energy of incident photons must be more than equal to work function of that metal. Work function varies from metal to metal. Sodium will have some work function, potassium will have some other work function. Therefore, the photoelectric effect occurs when energy is more than equal to work function. energy is given by HF. That should be more than equal to work function. Therefore, frequency should be more than equal to work function by H. This work function by H, we call it threshold frequency. So, F should be more than equal to F naught. Remember the formula for F naught? F naught is work function by Planck's constant. Now, instead of looking at frequency, you can look at wavelength also. So, this equation becomes Hc by lambda more than equal to work function. Therefore, Hc by work function should be more than equal to lambda, right? Lambda should be less than equal to Hc by work function. So, lambda is less than equal to lambda 0. This lambda 0 is threshold wavelength and that is Hc by work function. So, for photoelectric effect to occur, there are three conditions. All three are exactly same. If one is true, the other two will automatically be true. So, for photoelectric effect to occur, energy should be more than equal to work function. The frequency should be equal to more than equal to threshold frequency. And the wavelength should be less than equal to lambda 0. So, these are the conditions, or we can say this is the condition. There is one condition only, all three are same for photoelectric effect to occur. So, therefore, in this lesson we learned that for photoelectric effect to occur, the energy of incident photons must be more than or equal to the work function of that metal, and this implies the frequency has to be more than threshold frequency, and threshold frequency is given by work function by Planck's constant. The wavelength has to be less than equal to the threshold wavelength, and threshold wavelength is given by Hc by work function.